For thousands of years, humans walked across one of the most important materials on Earth, without ever knowing it was there. It was beneath their feet, buried in mountains, mixed into soil, scattered through rocks beside ancient rivers. And to the human eye, it looked like nothing more than ordinary stone, but hidden inside that dull, reddish rock, was a metal that would eventually build weapons, transform farming, carry railways across continents, and hold up cities that seemed to touch the sky. The strange part? Humans already knew iron existed. They had seen it fall from the heavens, but the iron buried beneath their feet was trapped inside stone, and for thousands of years, no one knew how to unlock it. So how do you discover a metal, when the metal doesn't look like metal? Who was the first person to throw an ordinary rock into a fire, and realize something completely different was hiding inside? We don't know their name. We may never know where it happened, because the discovery of iron probably wasn't one brilliant moment. It was a chain of accidents, experiments, failures, and observations, passed from one generation to the next, and the story may have begun, not underground, but above them. Imagine standing in the ancient world at night, no electric lights, no glowing cities, just darkness, cold air, stars, and the flickering light of a fire. Then suddenly, something tears across the sky, a flash, a burning trail, and somewhere beyond the settlement, a stone crashes into the earth. Later, someone finds it. It feels different, heavier than an ordinary rock, hard beneath the hammer, and when its surface is polished, something strange appears: metal. Some meteorites contain metallic iron mixed with nickel. Ancient people could work this material long before they understood how to extract iron from earthly rocks. To them, it must have seemed almost impossible. A metal had fallen from the sky, but there was a problem. Meteorites were rare. There simply wasn't enough of them. A small blade, a ceremonial object, an ornament. Perhaps, but enough metal for an entire army? Enough for a civilization? Impossible. So eventually, another question had to be answered. Could humans make this mysterious metal themselves? To understand how difficult it was, we have to go backward. Long before the Iron Age, humans had already learned something extraordinary. They could control fire. They discovered that certain stones changed when heated. Copper ores could produce copper. Copper could be combined with tin, and bronze became one of the great materials of the ancient world. But bronze had a weakness. It depended on two metals. Copper was relatively widespread. Tin was much harder to obtain. That meant bronze depended on mines, trade routes, and distant communities connected by fragile networks. And when those networks began to break down near the end of the Bronze Age, the need for locally available materials became even more important. Beneath their feet was one possible answer: iron ore. There was only one problem. Finding iron ore was easy, getting the iron out was not. Iron in the earth usually wasn't shiny. It wasn't a silver-colored bar waiting to be picked up. It was locked together with oxygen and other elements. It could look red, brown, black, heavy, ordinary. A person could stare directly at an iron-rich rock, and have no obvious reason to believe something valuable was hiding inside. And this is where the story takes its most important turn, because the first person to produce iron didn't need to understand chemistry, they needed to understand fire. Ancient metal workers had already spent generations learning how to make furnaces hotter and more reliable. They discovered that charcoal behaved differently from ordinary wood. They improved airflow. They experimented with different ores, different fuels, different temperatures, and eventually, some furnaces became capable of doing something extraordinary. They could take oxygen away from iron ore. The iron didn't need to melt. The oxygen simply had to be removed. Inside the hot charcoal furnace, gases produced by the burning fuel reacted with the iron oxide, slowly stripping away its oxygen. The stone began to change, and somewhere inside that furnace, metallic iron started forming. But what came out didn't look like the iron we know today. It wasn't a shining bar. It wasn't a pool of liquid metal. It was a rough, porous mass, filled with iron and trapped slag, a bloom. And now imagine the person standing over that furnace, looking down. trying to understand what the fire had made. Was it useless? Was it waste? Or was there something hidden inside it? There was only one way to find out: heat it. Place it on the anvil, strike it. The hammer came down, once. Then again, and again. Metal rang through the workshop, each blow squeezed out impurities, and compacted the strange mass, slowly. Something that had looked almost worthless, became workable iron. Stone had become metal, but the discovery created another problem. Iron wasn't automatically better than bronze. Early iron could be soft, a blade could bend, an edge could wear down. A skilled bronze worker could still make an excellent weapon. So why struggle with this difficult new material? Because the story wasn't finished. Blacksmiths began noticing something. Iron changed depending on how it was heated, how it was cooled, and what surrounded it inside the furnace. Then came another crucial discovery. Under the right conditions, carbon could enter hot iron, and change its properties dramatically. The result could become harder, stronger, and far more useful. The ancient craftsman didn't know about carbon atoms. He didn't know about crystal structures. He didn't know the chemistry behind the transformation. He simply watched what happened. Change the fuel. The metal changes. Change the airflow. The furnace changes. Change the heat. The metal changes. Change the cooling. The blade changes. And that was enough. Generation after generation, those observations became knowledge. A craft became a tradition became technology, and eventually, iron could become steel. Not the perfectly controlled steel produced in modern factories, but a powerful material that could be hardened and shaped into stronger tools and weapons. Now iron had another enormous advantage. Its raw material was widely distributed. A community didn't necessarily need distant sources of tin. It needed ore, fuel, a furnace, and someone who knew the craft. That could change everything. Iron axes made clearing forests easier. Iron agricultural tools could improve cultivation. Iron chisels and cutting tools expanded what builders and craftsmen could accomplish. Iron nails, chains, fittings, and countless other objects changed construction and transport. The material slowly moved from the workshop into everyday life, and that may have been the real revolution. Iron didn't simply create stronger swords, it made useful metal more accessible, and there was never just one path to mastering it. Different societies developed different techniques. In the West, bloomery furnaces became a major route to workable iron. In China, large-scale cast iron traditions appeared remarkably early. In South Asia, metal workers developed sophisticated traditions of carburized steel, and across Africa, independent iron working traditions emerged in different regions, with furnace designs adapted to local environments. There was no single ancient inventor holding the secret, no laboratory, no instruction manual. There were workshops, furnaces, apprentices, failures, and memory. One craftsman discovered that a certain ore produced a better bloom, another learned that changing the airflow improved the furnace, another found that a different heating or cooling process created a harder blade. Then those lessons passed to the next generation. The process was slow, sometimes painfully slow, but knowledge accumulated, until something that once seemed impossible, became repeatable. And that is one of the most remarkable things about ancient technology. Our ancestors didn't need to understand the science before they could master the process. They learned by watching, by failing, by remembering, by trying again, by listening to the sound of metal beneath a hammer, and watching what happened inside the fire. Once iron working became established, its effects reached far beyond weapons. Farming changed, construction changed, forests could be cleared more efficiently, tools became stronger, production increased, and humans kept pushing the technology further. Furnaces became larger, temperatures became higher, techniques became more specialized. Some societies learned to produce liquid iron, and centuries later, industrial processes transformed steelmaking again. In the 19th century, methods such as the Bessemer process made mass-producing steel dramatically faster and cheaper. The scale had changed, the technology had evolved, but the fundamental challenge was still connected to that ancient furnace. Take iron from its mineral form, control the heat, control the carbon, control what enters the metal, and what leaves it, and today, that ancient discovery surrounds us, the bridge outside your window, the train crossing a city, the steel inside a skyscraper, the machines inside a factory, the ship moving across an ocean, the tools used to build almost everything around us, all of them belong to a story that began long before modern science existed, a story that began with people who couldn't explain the chemistry, but refused to stop experimenting with fire. And perhaps that is the most extraordinary part. We often imagine technological revolutions beginning with brilliant people, people who understand exactly what they're doing, but history is rarely that clean. Sometimes a breakthrough begins with a question, sometimes with an accident, sometimes with a failure that teaches someone what not to do, and sometimes it begins with a person staring at an ordinary rock. They don't know it contains iron, they don't know what iron can become. They don't know about steel, they don't know about engines, railways, bridges, ships, factories, or skyscrapers. They only know that something strange happened inside the fire, so they try again, and that second attempt leads to another, and another. Until somewhere along that enormous chain of human experimentation, stone becomes metal, metal becomes technology, and technology begins reshaping civilization. The iron was already in the earth. The possibility was already there. Humanity didn't discover the existence of iron. We discovered how to unlock it, and perhaps that is the deeper story of human invention. The world has always been full of hidden possibilities, waiting beneath the ordinary, waiting inside things we barely notice. The difference is that every once in a while, someone looks at the ordinary, and asks an extraordinary question: what happens if I try?